All right. In this lecture, we're going to introduce the concept of limit, and the limit is the foundation of everything we do in calculus. So it's very important. Now, I've already drawn a graph of a function f of x to illustrate different kind of limits through which you can understand what we mean in general by limits. All right. So the black curve is the graph of f of x. Along the graph, I pick up a point p0 at a location x0, another point p at the location x. So x0 is fixed. Well, x will move. As x moves towards x0, we're going to see a few things that are happening accordingly. So before we get to that, let me talk about other involved quantities, things. So in addition to points, I pick it up. Now let's see, at a location x, there's point p, right? The height of this p, by definition of the graph, how we graph it, is actually the function value. So I mark it as f of x. At a location x0, the height of p0 is the function value, f of x0. So I already kind of list them, points, there's p, there's p0. Accordingly, the height of each point is f of x, f of x0 respectively. There are also function values at respective locations. One more thing. Through P0 and P, we can draw a straight line in red. That's called the secant line. Line going through 2 points. At P0, we can draw a tangent line, a line that barely touches P0. All right? So now, we're going to push x towards x0. Okay? Let me mark it here. So x approaches x0. Accordingly, we can see, first thing, the point at the location x on the graph will approach p0, right? As x approaches x0, the point will move along the graph toward p0. We denote this result as using the limit notation. So we say limit of p as x goes to x0 is p0. So limit, you can see here, is like the trend of this moving point. As x goes to x0, p eventually will move towards p0, the trend of a moving point. All right. So this is one example of limit. Next, let's examine the value. So the value of f of x is also the y-coordinate of p, or the height of p, right? Now, let's look. When x approaches x0, we can see as p moves along the graph towards p0, the height of P, point P, of course, will approach the high of P0, which is f of x0. So we denote this result also using the limit notation. We said in mathematics, limit of f of x as x goes to x0 is f of x0. So this is another example of limit. There's more. Again, we are letting x approach x0. Look at what happened to the lines. So through P0 and P, there is a seeking line going through 2 points. P0 is not moving. As we see, as x approaches x0, we see the red line is coming down, approaching the tangent line. Then we say the limit, using the limit concept, we say the limit of seeking line L as x goes to x0 is the tangent line, right? So basically the red line approaches or becoming the yellow tangent line. All right, one more thing. Well, this last example is based on the fact that as x approaches x0, the red line approaches yellow line. Because look, when the red line approaches the yellow line, the slope of red line, which I already write here, this is slope of a line going through 2 points, change in function value divided by change in x value, right? Will approach the slope of this yellow line, obviously, because the line approaches, the red line approaches the yellow line. Of course, the slope of the red line is getting closer and closer, approaching the slope of yellow line. So again, we denote this result using the limit notation as limit of the slope of red line as x goes to x0 is m, which is slope of the yellow line. So with this one graph, we can see various kind of limits. So hopefully you get some understanding of what the limit is. Limit basically is a trend of some things. Could be the trend of moving points, the trend of bunch of values, the trend of lines, or whatever. Slope is basically some kind of a value too. All right. So there are all kinds of limits in mathematics, in calculus in particular. We mostly examine limit of values. Well, the last one is the limit of value too. Like I said, because slope is a value, right? This one is extremely important because it is what we will call derivative. All right, we'll talk about in later sections when derivative is introduced. But anyway, so this is basically what limits are about. All right. Now, based on the last result, like I said, it's very important. So we want to talk more about it. Now, from the graph we had here, we find out that this kind of limit is actually slope of a tangent line, right? At x0, the fixed point. So here we kind of summarize it. Just as a sort of an application of limit, right? So at the location A, which I called x0, right? This limit would give us slope of a tangent line, as we talk about. All right. So here is when we talk about limit, the limit can be calculated here to get slope of a tangent line. So it's called a slope formula, right? Now, for quadratic function, second order function, in general, px squared plus qx plus r, pqr are given. If we do the limit, we would find the result to be 2pa plus q. Now, we don't know how to do the limit. It's just here in many textbooks. In the beginning, they always mentioned, for this very typical, very special, simple function, second order polynomial function, the result is given right away. Of course, later on, once we know how to evaluate the limit, it's a piece of cake to derive this formula for ourselves. All right, so just want to mention this. All right, so well, in this section, the main thing is to understand, what we mean by limit. So we got a few examples, and there's really not much actual work we need to do in this section, except because this kind of limit is very, very important in calculus. So we're going to just do a little bit more in this regard, involving this kind of limit. And there's not much we can do because we actually don't know how to do the limit, right? So we're going to just use the given result. So this is called the slope predictor formula for quadratic function. And next, we're going to see an example how to write an equation of a tangent line. So here, let's review the formula for equation of a straight line, just so we can apply the result here to do something. All right, so formula of equation of a line is y minus y0 equal to slope times x minus x0 for a line with a slope m through 2 points, x0, y0. All right, so now let's see the example. Find an equation of the tangent line to the graph of f of x at x equal to 1. So this is a location A. The A here or here. All right. Now, graphing is not required. I just want to draw something that may not even be actually the graph, just an illustration to show what we're trying to accomplish here. So suppose the graph is like this. So this location is 1. We want to write an equation of tangent line here. All right. So the first thing is according to the formula for line, for tangent line. Tangent line is straight line. So we're gonna first of all find the points on the line, one point on the line, and the slope of a line. Point on the line, it's pretty simple. You'll see. Slope of the line is the key. We're going to use this formula because it's a tangent line. This is formula for slope of a tangent line. All right. So let's first figure out the point. At 1, to figure the point would be 1 as x-coordinate. Now y-coordinate will be actual function value. So we can just plug in x equal 1 for x to calculate. So it'd be actually f of 1. Now that's easy. Plug in 1 for x. We're going to see it's 4 minus 3 plus 2. It's going to be 3. So it's actually 3. So this point is 3. So a point we find on the graph is 1, 3. 1 is x coordinate, 3 is y coordinate. What about slope? Well, slope is the main thing. So we would do m1 equal to 2p. Let me write down the formula first. 2pa plus q. Let's recall the formula here. Right? This is the formula for slope of tangent line at location A. So A is 1, so it's going to be 2 times P. P is coefficient of x squared. It's 4 times 1 plus Q. Q is coefficient of x. That's negative 3. So what is this? It's 5. 2, 4, 8. 8 minus 3 is 5. So slope is 5. Coordinates of a point are 1, 3. And then we just plug into the formula here. Y minus y0 equal to slope times x minus x0. So the equation of line is going to be y minus y0, 3, equal to slope times x minus 1. We don't need to simplify. So this will be the equation of tangent line, which I actually had as line. All right, this graph is just a demonstration. It may not be the actual graph. This just shows you what we're trying to do in this example. All right, to summarize, in this video, we basically introduce main thing. We introduce concept of limit through various things, right? Point approaching point, value approaching value, line approaching line, coordinate, slope of line approaching slope of this tangent line down here. All right.